Okay, hello everyone. This is the explanation in how you answer the quiz of chapter 18. It's about the wave. So basically this quiz is about the progressive wave and the quantity of it, and after that Doppler effect and also electromagnetic wave. So we're gonna discuss the question one by one. So in here I hope through the video you know how to answer this kind of a question. So let's begin. For question 1a, it's gonna be only 1 point. So in here you have to explain the meaning of the progressive wave. You can write like this. It's a wave. It's a wave that needs medium to travel. Okay, this is progressive wave, and you will get 1 point. And 1b, it's gonna be two difference between longitudinal and transverse wave. The first, you know that they have different direction of vibration. So you can say here transverse wave. You can write the vibration is perpendicular to the direction of travel, and this is the longitudinal. Here you can write that the vibration is parallel. The symbol for me is this one, to the direction of the travel. This is the first difference. What is the second one? The second one, we can talk about the appearance. In the transverse wave, there will be crest and through. How about the longitudinal wave? There will be compression and rarefaction. Okay, that is the question 1b. Now we're gonna have 1c. 1c related to the this diagram. So it's a transverse wave, and as you can see we have two diagrams. The first one is this one, and as you can see the two diagram has the similar shape of the wave, but they have different quantity for the x-axis. For the first one, it's only distance, so any data in the x-axis is distance. Like this one, 4 means 4 centimeter. And for the second one, the x-axis is in time, and you can see that 4 here means 4 seconds. Now you have to tell me what's the amplitude. Remember, amplitude is the displacement, maximum one, from the equilibrium. What is equilibrium? It's when the displacement is 0, this one. So whether you take the first diagram or the second one, both of them in the y-axis is the same, displacement. So the maximum displacement is this one. This is the maximum displacement or amplitude. And you can see the number is 1. And look at the unit. The unit is in millimeter. You write it in millimeter or you convert it into meter. That's okay. Both of them will be 1 point. And then what about the next one? It's about the wavelength. What is the wavelength? For the wavelength, you have to take the x-axis, and the x-axis must be the distance. And since this one transverse wave, one wave will be one crest, one through. And since we talk about the wavelength, so we have to take the first diagram. Do you know why? Because in the x-axis it's distance. So let's see, one crest, one through. this is one crest, this is one true, and the distance between them, or the length of this one, is this one, from 0 until 4. So what's the answer? Yes, it's gonna be 4 centimeter, or when you convert it to meter, it's gonna be 4 times 10 to the power of -2 meter. Next, it's about the period. What is period? Period is a time to do one wave. You know, we have one wave already in the diagram 1. So if we want to talk about the time, we have to use the second diagram. Because in the second diagram, the x-axis here is in time. So, when again, period is time to do one wave. One wave is one crest and one true. So, look at the time. It's from 0 until 4. Yeah, of course, the period will be 4. And the unit for it is this one, second. So that is, everyone, how you answer the question number 1. And for 1C, it's gonna be 1 point if you can write the answer correctly. Oh, we have D in here. So let's see D. It's 1D. The following diagram is the diagram of the sound wave. And then what is the phase difference? Okay, phase difference, make sure it's in degree. Yeah. And then what is it? This one, if we have a section like this, this means 90 degree for a section like this one. Okay, so later we can know the phase difference by counting how many sections and then times it with 90 degree. So let's see the question one by one. I'm gonna use the green one for the point AB. So for the AB, let's see the phase difference. I'm gonna write just PD for the phase difference. So A and C. So this is the beginning. This is the end. So look how many sections? 1 and 2. So we have 2 sections for this. So it means 2 times 1 section is 90 degree. Alright, so it's gonna be 180 degree. That is for AB. Now I'm gonna use the orange one for BE. Okay, so look at B here. So this is the beginning. And E here. So this is the end. So let's count how many sections. 1, 2, and 3. So the PD will be 3 times 90 degree, which is 270 degree. Alright, the next one, we're gonna use the A until F. So the A here and the F is here. So let's count the section. It's 1, 2, 3, and then 4, and then 5. Okay, so we have 5 for the AF. So the PD will be 5 times 90 degree, which is 150 degree. Alright, that is the it's 3 points. So when you get the correct answer for every potent PD phase difference, you will get 1 point. Let's continue with the question number 2. The question number 2 basically is a question about to find frequency in the CRO. What is CRO? Sorry, CRO means cathode ray oscilloscope. So let's see. When a sound wave is displayed on a CRO screen, cathode ray oscilloscope screen, 2 complete wave occupy 5 scale division. So that means 2 wave like this occupy how many? 5 division. So in here you can say 2 wave is how many division? 5 division. So for 1 wave it's gonna be 5/2 or 2.5 division. Now here the calibrated time base is set up on so 1 division is equal to 0.005 second. And then now you have to determine the period. Now period means you have to use the 1 wave. Why? Because period basically the time to do 1 wave. So 1 wave is 2.5 division. For the period it's gonna be 2.5 plus 1 division is 0.005. And then if you use the calculator, wait a minute, the answer is 0.0125, and it's already in second. Or you can write it in 1.25 times 10 to the power of -2 second. Like that. That is for 2A. Let's continue to 2B. 2B is the same. It's still about the CRO. Now in here, the time base is different. It's 5 millisecond. Remember in here it's millisecond, not meter second for 1 division. So let's calculate first. We have how many wave for how many division. To make it easier, you can take this one. Yeah, remember, take the first beginning for the crest must be in the vertical line, exactly in the vertical line, and then find again. This cannot, because look, the peak is not in exactly in the vertical line, so we cannot take the peak one. How about this one, the end of the crest or the true? This one cannot. Yeah, this one cannot, this one cannot, this one cannot, this one can, sorry, this one can, because it's exactly at the what is it, vertical, and the edge of the crest is already, yeah, similar point. How about the bottom? Now the bottom also cannot, yeah, because the bottom one is not in the vertical line. So we're gonna use this and this. What should you do? You have to calculate first the wave. How many wave? Remember, 1 wave is 1 crest, 1 through. So this is 1, and after that this is 2. Now this is only a half. So in here we have 2.5 wave. Correct? Yes. So you can write on the right is 2.5 wave is equal to, now how many division? It's 1, 2, 3, 4, 5, 6, 7. So it's 7 division. So let's find how many division for 1 wave. 1 wave is equal to 7 divided by 2.5 division. So it's gonna be 2.8 division. That is for 1 wave. Now you have to find the period, but before that, what about the time for 1 division? The time for 1 division, you can get it from here. The time is 1 division is equal to 5 millisecond. What is millisecond again? It's gonna be 5 times 10 to the power of -3 second. Okay, so from this and this, we can get the period. What is that? The period is 2.8 division, means times 5 times 10 to the power of minus 3. Let's see the result. Okay, it's 14 times 10 to the power of minus 3 second. That is period. Okay, you will get 2 points until this. After that, we have to find the frequency. Frequency is 1 over period. 1 over period. That means 1 over 14 times 10 to the power of minus 3. So use your calculator. You will get 71.4. So I'm going to just write 71 as the result, and frequency, the unit must be in hertz. So this is the answer for 2B. To be, basically 2 is about the CRO. And then let's see, do we have another question for B? No. This is the question number 3. The question number 3, as you can see, everyone, it's if you read the questions before, it's basically about the intensity and the wavelength, the relation between them. So let's start the question. 3A. The following diagram shows the 2 traces of the sound wave. So we have 2 sound wave, and if I say this is A, this is B, or you can say the A, the position is at top, or you can say this is the first wave. For the B, it's the bottom one, so you can say it's the bottom wave, or the second wave. So now which wave has greater amplitude? Remember, amplitude is the displacement, maximum displacement from equilibrium. So find the equilibrium first. This is for the first wave. It's the equilibrium. And the second wave, I think the equilibrium must be from here. Now, the amplitude of the wave, you can see how many divisions? The first wave have only 2 divisions for the amplitude. For this one, as you can see, it has 1.5. For the first wave, it has 1 division for the amplitude. For the second wave, it has 1.5 division. So which one has the greater amplitude? Of course, the answer is what we call it before? Wave 1. Wave 2. Because wave 2 is 1.5. That is for I. How about the double I? The double I, which means has a greater wavelength. Remember, what is wavelength? Wavelength is 1 crest, 1 true. Okay, I'm gonna use the different color for the wavelength. I'm gonna use the green one. So for the wave 1, or the first wave, it's gonna be only 2, right? The lambda is 2 division for the wave 1. How about the wave 2? For the wave 2, let's say if we begin from here, it will also end in here. And as you can see, maybe this to this is around 1 1 division, and this one also 1 division. And I think both of them is quite have similar wavelength. So you can also say in here wave 2 has the same division also. So since wavelength 1 and wavelength 2 the same, so you can say both of them have same wavelength, like that. Okay, how about the triple I? For the triple I, you have to calculate the ratio of the intensity. What does it mean? Remember, intensity has relation with the amplitude, which means amplitude square. So if we compare amplitude 1 with the amplitude 2, you can change the proportionality with the equality, but make sure the position of the index is the same, because it's directly proportional. So A1 square divided by A2 square. Now we're gonna use this relation. Okay, and here for the A1 is 1 division, for the A2 it's 1.5. So you can say it's 1 I1 over I2. Remember, ratio basically, yeah, the what we call it, comparison between them. So in here I compare I1 with I2. So in here you will get 1 square divided by 1.5 square. So at the end, the answers is gonna be 4 over 9, like this. Or you can make it into decimal, become 0.44, like this. So that is 3A. So let's continue to 3B. For the 3B, wave from a source have an amplitude of 3 centimeter. So we have amplitude 3 centimeter. With this data, we have the intensity of 200 watt per meter square, like this. Now we increase the amplitude, become how many? It's 12 centimeter. Or if you compare, it's gonna be 4 times. So what is the intensity? So I'm here to make the intensity second first one. I mean, like, I write the intensity of the second compare with the intensity of the first one. So it's gonna be amplitude the second divided by amplitude the first, like this. So you can change the equations into A2 divided by A1. Since A2 and A1 both of them in square, so I can make it like this, square, and then times I1. Let's submit the data. A2 is, sorry, I have not make the index for the A, is A1 I1 A2 I2. So the A2 is 12 divided by A1 is 3 square times the I1 is 200. So by use the calculator is 4 square times 200. Okay, 200, yes. The answer is 3200. And what's the unit? Follow the unit of the intensity here. It's gonna be watt per meter square, like that. That is 3B. Let's continue because we still have 4, 5, and 6. So it's for the number 4. 4A. Basically, question number 4 is about wave speed. So remember first the equation of wave speed. What is it? Wave speed is equal to wavelength times frequency, or wavelength times period. And again, remember, what is this one? We call this as lambda. Okay, 4A. What's the data we have here? We have the frequency. Frequency is 250, already an SI unit, no need to convert. And the speed, the V, is in 340 meter per second. In here you have to find the wavelength. So remember the equation is wavelength times frequency, which is to find the what is it? Wavelength. It's wave speed divided by frequency, or 340 divided by 250. So the answer must be 1.36, and this is wavelength. and hertz, meter per second is already in SI unit, so for the wavelength the unit will be meter. Now for the 4B I'm gonna write here, so later for the 4C we will write here. Okay, 4B, middle A, this is a note on a piano tuned to concert pitch, should have a frequency of 440. So we have the frequency 440 Hertz. If the speed, okay, we have V 330 meter per second. Calculate the wavelength. This is also the same, yeah. So we were gonna use the same equation like this. So it's 330 divided by 440. What is it? The answer is 0.75 and the unit is meter. Like this. Next, it's the 4C. 4C, wave. Okay, we have a wave and it has frequency of 100 Hertz. So frequency is 100 Hertz. Okay, and the speed is 500 millisecond. Sorry everyone. It's meter per second. Without stating the magnitude, so you don't have to calculate what happened to its wavelength when its frequency increase. So this is the frequency, the second one. Now we have another frequency which is more than the frequency of the second one, right? What happened to the wavelength? And in here, the wave speed stay constant. So the second wave speed will be the same with the wave speed 1. How to find the wavelength? You can use the relation between the frequency and wavelength in here. Oh, I'm sorry. I think I write something wrong in here. Yeah, sorry everyone. So I'm gonna change this one. In here, the thing that I want to write before is this one. Wavelength is equal to the wave speed divided by frequency, like that. You can see the relation. When the wave speed is constant, the relation between wavelength is directly proportional to the frequency. So look at the question again. When we increase the wavelength, when increase the frequency, what happened with the wavelength? It's inversely proportional. So you can say the wavelength decrease. And explain your answer. Wavelength is this one. Inversely proportional to the frequency. That's gonna be 2 points. Okay, we have question number 5, and the question number 5 is about Doppler effect. You can say, what is Doppler effect? So basically, Doppler effect is change of frequency due to relative motion between source of wave and observer. So you know already when the the source of the wave or the sound moving toward the observer, the frequency will increase, and if it is moving away, the frequency will decrease. That's why there must be change of frequency, because the relative motion. 5B. Okay, we have the plane engines and the frequency, so it produces the sound, so it's going to be the source. So Fs, it's going to be 300 Hertz. And then flying away from the observer, remember what is flying away? The Vs, it's going to be positive. So it's 75 meter per second. determine the observed frequency, but in here the frequency of the wave or the frequency of the sound is already 330 meter per second. So the equation for the Doppler effect is FO, O mean observer, is V over V, because it's already plus the Vs, so I'm gonna write this plus Vs, and then it's time source frequency. So it's 330 divided by 330 plus 75 times 300. So I'm gonna use the calculator. And the answer is 244. Yeah, 244 its frequency hertz, like that. But for 5C, an astronomer observed light from a too distance. Oh, so we have star A and we have star B. The spectrum of the wavelength is 650. So for the star A, the wavelength is 950 nanometer. And for the, what we call it, star B, so I'm gonna write this one lambda A, this is lambda B, is the same, because in here, yeah, A and B have the same wavelength. So it's 650 nanometer. When measured in the laboratory, the same spectral line for B. Now, in here, it must be A. Okay, it must be A. And this is B. So for the A, the wavelength that is observed, so this is the source. This is the observed. So for the observed one, the, what we call it, the A, it's become 500 nanometer, so smaller than before. The lambda B, it's going to be 600 nanometer also. Okay, so what happened? Which star that is moving away from the observer, and which star that is moving toward the observer? Okay, this is basically the original paper, but I'm gonna, change this one to make it different. For the B, it's gonna be more than the original one, so 800. Okay, and then, yeah, because if it is, 600, there will be no different condition, but I want to make this one different condition. So how? In here, remember, for the Doppler effect, it's about the frequency, but in here, what happened? We have the wavelength, so you can use the relation of the wavelength and frequency before. Wavelength is this one, yeah, inversely proportional to the frequency. And then look at the A. For the A, this is for the A, the wavelength increase or decrease? Decrease, right? So what happened with the frequency? Frequency will increase. When the frequency increase, means star A moving or move where? Frequency increase toward the observer. For the B, the amplitude, the wavelength is increased, so the frequency will decrease. This is star B move away from observer. So the answer for I is gonna be B. For the double I, it's gonna be A. And then the explanation, yeah, that one. You have to explain the relation between wavelength and the frequency. That is question number 5. next is going to be question number 6. For the question number 6, it's going to be about electromagnetic wave. Okay, you can see we have 1, 2, 3, 4, 5, 6, 7 wave, and the 7 of them is basically the spectrum of the electromagnetic wave. We will start from radio wave, and then this is infrared. What is between them? It's gonna be microwave. So for the P is the microwave, and here I'm just write microwave and W. And then between infrared, after that invisible light, ultraviolet, X-ray, and what we call it, the edge is gamma ray. So you can write, because we have to find P, which is this one, P, and R is this one. Since this one is Q, you can say that the R is gamma rays, like that. It's gonna be 2 point. The arrow, now which arrow you have? The arrow, okay, wait a minute, the arrow is this one. As you can see, the arrow is going from the gamma ray to the radio wave. You know already, when it is gamma ray to the radio wave, what happened with the frequency? Frequency will decrease. So you can say this one decrease in frequency. And what happened with the wave speed? Yeah, wave speed is the inversely proportional, right? So the wave speed will, the opposite of decrease is increase. How if I write change and change? Cannot. That's gonna be 0, 0, because you have to indicate specifically, because also the, what we call it, the direction of the arrow is specific. Okay, next is gonna be B. B is about, what is it? It's about the relations with, you have to find the wavelength, and then you have to, what we call it, compare it with the, compare with what? With the table of the electromagnetic wave. Wait a minute, I'm gonna show you the table. Okay, this is the table from the radio wave until the gamma ray. So let's find the each, what is it, the distance here to become, what is it? So it's 6B, and it's the I. The I is 2 kilometer. What is 2 kilometer? Sorry, I will start from the wavelength. Okay, this is wavelength 2 kilometer. Converted into meter, it's 2 times 10 to the power of 3 meter. So what is it? 10 to the power of 3, it's in here, radio wave. So you can say it's radio waves. How about the second one? For the second one, the lambda is 800 nanometer. So it means 800 nanometer is 10 to the power of minus 9. So it's gonna be 8 times 10 to the power of minus 7 meter. What is it? Now you can see, everyone, it's around infrared and visible. But visible, the maximum one is 7, not 8. So it's gonna be this one. The wavelength is longer than the visible, so it is infrared. Okay, next, the next one, use the blue. It's gonna be 500 kHz, or it's 500 times 10 to the power of 3 Hertz, or I'm gonna make it 5 times 10 to the power of 5 Hertz. Now, how about this one? It's in frequency, but how to find the wavelength? Yeah, use the V is equal to lambda times F. So lambda is wave speed divided by frequency. The wave speed is electromagnetic wave, so it's 3 times 10 to the power of 8, since it's also in vacuum. Yeah, so 3 times 10 to the power of 8, and the frequency is 5 times 10 to the power of 5. So let's see what's the answer. So it's 0.6 times 10 to the power of 3, or 6 times 10 to the power of 2 meter. So 10 to the power of 2, what is it? It is the same like before. It's in here, radio wave. So you can write in here, the third wavelength is radio wave. Okay, that is everyone. So the total mark for this quiz is going to be 49. So I hope you can get the 49. Yeah, but if not, the score will be total mark. Sorry, total mark divided by the 49 times 100. Okay, thank you everyone. Hope you can understand the explanation for me, and thank you again.